Nanda, good evening, Konal. Behra, good evening, Rudraksh, Krishna, Sushil, Kumari, Vivek, Reddy, Ronal, Rishikesh, Suvara, Deep, Aditya, Sumit, Nishita, Asham, good evening. Good evening. Over here, Max, you can understand. If you write 3 as 0011, 6 should be 1100. That's all. Kumari, your doubt is cleared? And 1 each other. Getting any carry also to. No, Behra, it depends on the numbers you have taken. Okay. We have what is the operation you are performing? In 2421, Behra, if you take 2421, your another number is also 2421. Here, what is the advantage? Maximum is 4 here, maximum is 8 here, maximum is 4 here, maximum is 2 here. There is no chance of getting any carry here. Behra, I hope I can answer. You can understand this from your doubt. There is no chance of getting any carry in this case. But 8421, there is, if you add 2 8s, there is a chance of getting carry. This problem will occur when you have chance of getting carry. So, hi, good evening all. Good evening, good evening. Kumari, you can write, but it should satisfy self-complementary property. That is what I told. 3 and 6 should be complementary to each other. If you write 6 as 0, 1, 1, 0, your 3 must be written as 1, 0, 0, 1. If you write 3 as 0, 0, 1, 1, 6 should be 1, 1, 0. That's all. Kumari, your doubt is cleared? And yes, Behra, your doubt also cleared? There is no chance of getting carry here. That's why you will get right answer. Good evening, everybody. Fine. So let's start the regular class. So your good evening. This is Boolean algebra will be starting today, and also the leftover part of number systems. First, I will complete that part, and then I will come to this part. Fine. Okay. So now let's start the continuation. Yesterday class we have seen gray code, BCD codes, BCD arithmetic. Up to that we have discussed. Now the next part of the number systems. In the number systems chapter, last part will be data representation. This heading itself will tell you that what is data representation is how to represent positive numbers and negative numbers in your computer. Because computer can understand only ones and zeros, I should represent with these ones and zeros only both positive and negative numbers. Is it clear what I am saying? This data representation will tell you how to represent positive numbers and negative numbers in computer. Okay. Because computer can understand, good evening Rishabh, ones and zeros. We should represent both negative and positive numbers using this ones and zeros only. So let's start. Now we'll do at the end of the class. Actually, gray code problems are there that require some Boolean algebra also. Because I want to clear one more thing. Okay. Anyway, you asked Sushil. Today I will give you TPP for 22 questions. Some 20 questions on number systems, which cover almost everything. Okay. Tomorrow we'll be discussing all the 20 questions in the class also. Today you can try it as a practice. Tomorrow, anyway, it's a doubt session. We'll be doing it. Okay. And understand here, whatever we are discussing these number systems, questions on this not only end here. In Boolean algebra, in combinational circuits, in sequential circuits, using these codes, you will be getting the questions. There we will be discussing. Okay. So today at the end of the class, please remind me, I will upload the DPP. Okay. So let's continue with the class. Data representation. In the data representation, we have basically unsigned magnitude representation, signed magnitude representation. What happened? 1 minute. Okay, see here. In the data representation, you have class from 5 to 6:30 or 5 to 7. Oh, fine. You have half an hour break in between. Fine. So because it is the end of the day, don't exhaust here. Okay. Icon, be energetic. It is the last class, but it is important class. So last 5 hours in the match should be, we should play well, right? So keep that energy. So data representation contains unsigned magnitude, signed magnitude, one's complement, two's complement. Very good, very good. Shivam Har Har Mahadev, right? Today all teachers gave DPP. Yes. So first part is done, basics. So everybody starts. Now onwards you will be having more work. Every day you need to practice. Okay. Bharati, good evening. Okay. So let's continue. Data representation. Unsigned magnitude representation, signed, one's complement, two's complement. What is unsigned magnitude representation? Here there is no concept of negative numbers and positive numbers. We represent only positive numbers. So please listen. In unsigned magnitude representations, we represent only positive numbers. There is no negative numbers here. Okay. And if you have, please listen. If you have 4 bits, everybody see here. If you have 4 bits, my range is 4 zeros to 4 ones. 4 zeros to 4 1 can be written as 0 to 8421. Now, what is this? 15. That is 0 to 2 power 4 minus 1. So if you have n number of bits, what is the range here in the unsigned representation? 0 to 2 power n minus 1. Okay. Is this point clear to everybody? Okay. This is what we discussed just up to now. Here there is no concept of negative numbers. In this way, you can represent only positive numbers. But computer, how to represent a -5? This minus should be represented in terms of ones and zeros. Ones and zeros should only give you this minus. So for that we have other representations. We'll see now. I'm very happy today. 2 students, what Bharati and I think Behra, both of you have asked doubts based on previous lecture. It means you are working in the background. Okay, you are analyzing. You are doing some logical work. This is required. After every class, in the previous class, you do some experiments also. It will be very good. Why this is coming, why this is not coming. Next. So that is about your unsigned magnitude representation. The next one is a signed magnitude representation. Listen here. Forget about this. Don't read it until I say. Okay. Firstly, let me explain you. Then you can read it is proper way. So in the signed magnitude, we can represent both positive and negative numbers. Earlier only positive, here both. MSB. MSB means what? Most significant bit is dedicated for sign. Suppose you have the number. Number is divided into two parts now, sign and magnitude. Okay. So sign part can be 0 or sign part can be 1. And your magnitude will be containing the magnitude of the number. That is, it can be all zeros to all ones, depending on the number of bits available. Here also, it can be all zeros to all ones. Nanda, you are comfortable now with the speed? Now, you see, S is 0 means positive number. S is 1 means negative number is the notation we are following. So to represent the negative numbers, what we are doing? We are taking the first bit, we are dedicating as a sign. If sign is 1, okay, if sign is 1, negative number. Sign is 0, it is positive number. So now you can see it is a 0. This is +1. This is +7. What about this one? -0, -1, -7. So here, earlier your range is 0 to 15, but what is the range now? If you have n equal to 4 bits, you can represent from -7 to, yes, very good, very good, very good. -7 to +7. What happened, Kumari? Please see. If your first bit is 1, it is a negative number. If first bit is 0, it is a positive number. Okay. So you are having the range from -7 to +7. Okay. Now -7 can be written as -2 power 4 minus 1 minus 1 to, it is 4 bit only. It is 4 bit only, but 1 bit is gone for what? Sign. 2 power 4 minus 1 minus 1. So can I justify this answer or not? Yes or no? Right. So range is 2 power -2 power n minus 1 minus 1 to 2 power n minus 1. Now someone has asked, sir, why 0 is having two representations? Yes, this is a disadvantage here. Listen, if you take 0, 0 is having two representations in this way. One is +0, one is -0. +0 is kya? What is +0? All zeros. What is -0? First one and all zeros. 0 should be unique. You should not have +0 and -0. This is a disadvantage in this method. If you represent your numbers like this is a disadvantage. Okay, 1 point. Second point. Sir, in unsigned we use 2 power n. Yes, Simran, but -1 is outside. Like 0 to 2 power 4 minus 1. It is, this -1 is not in the numerator. It is outside. Yes. Now second point. Listen here. What repeat, Nidhi? 0 here is getting two different representations. For same number, we are getting two representations. It is one disadvantage in this. Okay. 0 is having two different representations. Here, first bit is dedicated for sign, remaining is dedicated for magnitude. So, first bit is one negative number, first bit is 0 positive number. Okay. This is unsigned. In the unsigned, only positive numbers, all zeros to all ones. Range is 0 to 2 power n minus 1. Now come here. Suppose you have n equal to, important point, carefully listen, n equal to 4 bits. How many bits I am having? 4 bits. What is +7? +7 is 0, 1, 1, 1. What is -7, my dear friends? -7 is 0, 1, 1. What is -7? 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 First bit only changes, remaining is same. Unsigned, there is no negative. Okay, Bhavesh, there is no negative number in the unsigned. It is signed. Yes, what you are saying is we are representing only 15 numbers with 4 bits. Okay, because 0 is taking 2 times. 0 is taking 2 times now. That's why we are getting 15 different numbers. Okay. Now I want to extend the range of this computer. That is my number of bits. I made it to 4 bit to 6 bit. My computer range extended. I want to represent the same number in 6 bit. 6 bit, what is the representation of this number? First plus 7. Plus 7 is 0 is first. After that 0, 0, triple 1. What is minus 7? Please listen carefully. 0, 0, triple 1. Is this point clear for everybody up to this? Very good. Now, if you make n equal to 8 bits, n equal to 8 bits, what is plus 7? 0 followed by 0, 0, 0, 0, 1, 1, 1. What is minus 7? Okay, minus 7 is 1 followed by 0, 0, 0, 0, 1, 1, 1. Very good. Now, what is the conclusion? If you have 8-bit representation, suddenly you want to represent the same number in 16-bit. Or if you have 4-bit representation in your computer, now suddenly you want to increase the number of bits to 6 bits. Same number you want to represent in 6-bit or 8-bit. Every time, what's happening, you see. Between this sign and magnitude, between the sign and magnitude, you are inserting zeros indirectly. After doing this, analyze. Okay, what is the process you need to do to increase 4 to 6 bits? Carefully listen. Okay, after writing this, okay, between sign and magnitude, extra what you are getting? 2 zeros. Here also same or not? Between sign and magnitude, you got extra how many zeros? 4 zeros. Same here also. Between sign and original magnitude, you got extra 2 zeros. Between sign and the previous magnitude, you got 4 zeros. What does it mean? What does it mean? To extend the number of bits, if n number of bits are increased, then I need to insert n zeros between where to where? Yes, some kind of zero padding you can say, but there you will be adding zeros intermediate, right? So I will write like this. To increase number of bits between sign and magnitude, we need to insert zeros. So extending the range is not easy. Extending the range is not easy in this representation. These are the disadvantages of this representation. Everybody, is it clear? Can I move further? -1. See, negative number, positive number here, don't remember it as a complement. What is negative number is only sign will change. Only sign will change. Remaining will come as it is. Only sign changes. Remaining will come as it is. Now you compare this -7 with this -7. What is the observation you are getting? Is it how you do it by hardware? Hardware implementation is not very easy now here. You should find in between. After first bit, you need to insert zeros. It will take some time. It will increase your delay of the system. It requires more hardware. You see here, to extend. Suppose you have 4-bit, suddenly you have updated to 6-bit system. 6-bit, you should represent the same number again. Then what to do? You should identify sign, magnitude part, in between you should insert zeros. You should identify sign, magnitude, in between you should insert zeros. This is what happens to represent the same number in 8-bit, 6-bit and 4-bit. This is the disadvantage here, and this is also disadvantage here. Is it okay for you? Okay, so let's move. Yes, 0 is not having any sign, but you are representing in two forms. That is also disadvantage, I told na. Okay, so now, not delay, we can say, implementation point of view, it requires extra effort. We want to make the system to work as easily as possible. Okay, if you implement this by hardware, I will show you the next method, ones complement, where your things are easy. Compared to that, it is a disadvantage. Just wait for few minutes. Now see here. Not memory directly. Okay, it depends on how you are implementing the system. Okay, listen here. We can overcome these disadvantages by using complementary representation. So what is complementary representation? In that we have two complementary representations. Let me start with the ones complement representation. Let me start with ones complement representation. Okay, so let's see. Right, Krishna? So let's start with the ones complement representation. Then I will show you twos complement representation. Then we can conclude. So the next one, signed ones complement representation. In a signed ones complement representation, if number is positive, it is represented as it is. Be careful, be understand. Positive numbers are represented as it is. How negative number is represented? By its ones complement. Number is positive, it is represented as it is. If number is negative, it is represented by its ones complement. Let me show you that thing. Can I move further? Right. So here also, you take positive number will be represented as it is. Positive numbers will be represented as it is. Zero, all zeros one, all zeros 1 0, like that 7 up to 7 will be represented. Positive numbers are represented as it is. How to represent negative numbers? I will show you. Before that, this is plus 0, plus 1, plus 2, and plus 3. What about negative numbers? Take complement. For negative numbers, take complement of this. Yeah, plus 7, I am sorry. plus 7, right? Take complement. What is the complement of this? Tell me, my dear friends, what is the complement of this? All zeros. What is the ones complement? Very good. Yesterday class we have already discussed. 1, all zeros. What is the ones complement of 0001? 1 and 110. Right. Next, what is the ones complement of this number? 1, 101. Lastly, 0111 is 1 and 000. Okay. So here your answer is -0. That problem is still present. We have not able to solve this here also. Okay. Now it is going from where to where? -7 to +7. So what is the range here? -7 to +7. Okay. Yeah, I'm sorry. That is my mistake. I'm sorry. In complement is all ones. I'm very sorry. Okay. So now listen here. The range is -7 to +7. Okay. This is -7 to -0. This is 0 to 7 total. Okay. You complete totally. It is -7 to +7. So total range we are speaking is -7 to +7. That is 2 power n minus 1 minus 1 to 2 power n minus 1 minus 1. Yeah, it is 4-bit only. Here n equal to 4-bit is my example. N is the number of bits. You should include sign also in your bit. Total, okay, total together is your bit. Here also, our intention is not sign, but by ones complement method also, for positive numbers, what is the MSB? What is the MSB of the positive numbers? Please tell me, everybody. 0. For negative numbers, what is the MSB you are getting? 1. So, whenever in the any sign representation, if first bit is 1, it indicates negative number. First bit 1, it indicates negative number. Yeah, first column is -7 to -0. Second column is 0 to 7. Total is what? -7 to +7. Okay. With 4 bits, all these are different combinations. I am able to do it. Yeah, range is same as a signed magnitude representation. Correct, Asif? Here also one disadvantage is there. 0 is having 2 representations. +0 and -0. +0 is all zeros. -0 is all ones. So still that disadvantage is present. But one disadvantage we can overcome here. Such we should count 14. If 0 is twice, then count 16. See, different numbers we are counting here. Okay, range is from where to where, not number of numbers here. Number of combinations is 16 only. Different combinations is different numbers. It is a range we are speaking. Range means from where to where. Kaha se kaha tak. Okay. Please listen. Whatever you have, take one's complement, you get this. If you take one's complement, you get this. All zeros, what is the one's complement? All ones. 0 triple 1, what is the one's complement? 1 triple 0. That's all. Range may don't confuse. Okay, range is all 4 bits say -7 to +7. Total, not one single column. I don't know you are present in the class or you came just now. This is over. This is over, my dear friend. Shushil. Okay, this part is done. Now we came to new method. What is that? One's complement representation. Leave that from your mind. Come to the new one. Okay, in this new one, we represent positive numbers as it is, negative numbers by one's complement. Is it okay? The previous method and this method not same. Okay, whatever may be n, substitute the n here and you get the answer. If you have 6 bits, minus 31 to plus 31, that's all. It is not like signed magnitude. Only sign may be representing same. It is not like signed magnitude. Yeah, what is the advantage of 1's complement, Bhavesh? Now I am coming to that point only. Okay, first understand. I don't know what is your problem, Kunal. I have explained this much. Please see properly. What is your doubt? Ask me properly. Kunal, please ask me what your doubt. I can explain you betterly, no problem. If you have 4 bits, it is not 0 to 15 because half are taken by negative numbers, half are taken by positive numbers. Things are not like same. Okay, earlier you have only positive numbers, it is 0 to 15. Okay, but here half are taken by negative, half are taken by positive. That's why it is minus 7 to plus 7. Okay, yes, exactly same, Akash. MSB is not intentionally signed, but after taking complement, if you see MSB, you can say it is a sign. Here MSB is not dedicated originally for sign. Okay, but after taking complement, what you can see is MSB is indirectly giving you sign information. So let's move. Okay. Now, why 1's complement? Is there any advantage in this? Let's see. If you have same problem, let me take 4-bit representation. N equal to 4-bit. What is plus 7? 0, 111. What is minus 7? 1, 000. Now you see what is 6-bit. What is plus 7? 0, 0, 0, 1, 1, 1. What is minus 7? 1. Okay. Its complement. Don't see the previous number. Take its complement. What is its complement? 111, 000. Very good. If you take 8-bit, what is minus 7? What is plus 7? 0, all zeros, 1, 1, 1. What is minus 7? Its complement. What is its complement? 1, 1, 1, 1, 1, 000. 1's complement representation is negative is complement of positive. Now you see here extending the range is easy. It is not inserting zeros between this. It may be true here, it is not true here. So what is the common logic you can develop here is suppose you you extend this number into 4 to 6 bit. You see nothing but copy the MSB 2 times. What is that? It is called as a sign extension. Just copy this n number of times. You got the same or not here also? Now come here. For negative also it is true. Negative first bit is 1. Now 3 ones. Now all ones. So if you want suppose the 16-bit representation of minus 7, no need to worry. You have this now. Add all ones. Your job is done. Now doing this job will take less hardware to the computer compared to previous one. That's why it is advantages for us. Or no, this is easy for you and for your computer also. So this is advantage for us. Okay, so can I write this point? What happened, Aman? MSB is not represent. Can we use 4-bit double? See, if it is not representing sign, it is an unsigned representation. And 1100 is 12. In the signed representation, okay, there is no other option. You never get 1010 as 10. Okay. Here, please listen. Advantage. Extending range is easy. Copy MSB repeatedly. We call it as sign extension. What is this name? Technically, we call it as a sign extension. When in signed representation, if the MSB is repeated, it is just a sign extension. It is not having any information. That is 111, 000, 5 ones, 000, all ones, 000. Everything is representing the same number here. Yes. Okay. This is a sign extension only. System don't know, my dear brother, you will be knowing it. We'll follow the same syntax when you manufacturer, your processor designer will specify how you have made the system. We'll follow the same. If you use other format, you should use some kind of converter. Okay, your compilers, etc. will take care of those things. Okay, next. After every class, okay, today in the class itself, I will upload the DPP. After every class, you can download the PDF. It is available in the Unacademy app. I will also provide in the groups. Okay, both are available. Now, ones complement arithmetic. What is ones complement arithmetic? If you want to do according to this, a minus b, it is equal to a plus ones complement of b. I will prove it, just wait for some time. A plus ones complement of b. Is it okay? Please tell me here. Very good, very good. So a plus ones complement of b. A minus b can be written as a plus ones complement of b. Using this principle, I want to do 5. What is 5? 0, 1, 0, 1. Let me take 3. What is 3? 0, 0, 1, 1. Let me write next page, it will be better, I think. More space we will be getting. So what is 5? 0, 1, 0, 1. What is 3? 0, 0, 1, 1. What is minus 5? What is minus 5? 1's complement of 5, my dear friends. 1's complement of 5 is 1, 0, 1, 0. What is minus 3? 1's complement of 3, 1, 1, 0, 0. Okay. So now, listen. If you want to perform 5 minus 3, one minute here. This is for this, this is for this. Okay. If you want to perform 5 minus 3, how do you perform 5 minus 3? You know 5 minus 3 is 2. Everybody knows or not? So you take 5. Minus 3 means don't take minus 3. You should take it as plus 1's complement of 3. That is, what is 1's complement of 3? What is 1's complement of 3? 1, 1, 0, 0. Now add this. What is the answer? 1, 0. 1 plus 1 plus 1 is 3. 3 means 1, 1. 1 plus 1 is sum 0. Sum 0 and carry 1. What is this? Carry. Now your problem is not yet done. Still, I did wrong. Oh, so I forgot additions. Thank you. So where I am wrong? Double one double zero. This is 0 1 0 1 0. Yeah. Right. Sometimes it happens. So this is 0 1 plus 1 sum 0 carry 1. 1 plus 1 sum 0 carry 1. Okay. Now take after this problem is not at end. Now you take this one and add it back. Take this one and add it back. Then you will get the result. What is this? 1 plus 1 is sum 0. Now again what will you get? Carry 1. This is your answer. Okay, process I am explaining again. See, if you want to do 5 minus 3, you take 5, 1's complement of 3, add together, then you get a sum and carry. This is the carry. This MSB is there now. You take this back and add it to the result. Take this, add it back to the result, you get the final answer. What is this 0 0 1 0 means? 0 0 means 2. You know it, right? You got the same answer. You accepted. We have done only addition, but you are able to get the result. Okay. If no carry is there, okay. If no carry is there, 3 minus 5, then what is the answer? Minus 2. It won't generate, Rishi. Okay. There is no possibility because the result range will decrease. Two possibilities are there. Now see here, because you are subtracting, the number cannot be greater than your maximum number. Now 3 minus 5. So 3 should be taken as it is. 5 should be taken as. I am very happy you people are asking, or now feel free to ask anything from me. So I am very happy for that. Whatever doubts you are getting, you are able to express here. Now minus 5 means to take 1 0 1 0. So 1 will come here. 1 plus 1. 1 plus 1. Sum 0. Carry 1. Sum 1. Carry 0. Now 1. Oh, no carry. Krishna asked, I think there is no carry. What to do, sir? No carry indicates answer is negative. What is your answer? If there is no carry, what does it mean? Answer is negative, and it is in 1's complement form. Negative number will be in 1's complement only. Okay. So yeah, you can say like that also, similar, right? So now see here. But that is not true if you get carry. Okay. Generally, it won't happen. Now see here. Where we are. So 1101. You go back. What is 1101? What is 1101? Tell me here. Comment -2. Okay. So you got the answer right. Yes or no? 1101 means -2. Okay. Or please listen. Please listen. Sir, every time I cannot check that table. So what to do? Wait here. Let me complete. Or to know answer magnitude. Instead of checking that table and coming back, you want to know the answer magnitude complement. Then 1101 complement is how much? 0010. This will tell you what is your magnitude. But you should take it as minus. This will tell you only magnitude. Then you take minus, you will get. This is to understand the answer. This is just to understand your answer. Okay, I hope you understand what is 1's complement process. Okay, two people got some doubts. Let me clear that and we can proceed further. What is the Aditya doubt? Sir, 1's complement representation always Yeah, listen here. We are using one's complement representation or signed one's complement. Both are same. Unless he say give some bit pattern and ask you to find one's complement. One's complement representation means this one only. What is the decimal? What is Krishna? What is your doubt? Decimal equivalent of each bit means what? If it is 8421, you can write that 8421. Okay. For this, if you want, you should write one's complement means r power n minus 1 minus number minus 8421 code of this number. What is that? 1010. Like that you can do. What is 1010? 10 minus 1. What is your n? 4 bits. Base is 2. Okay, 15 minus 10. This is fine. But negative number. Okay. So any method you do, all reverse engineering, it will work definitely. Okay. Others, okay. I will definitely tell. I have already made the slide. I have typed everything for this. Yes, Akash. Very good. Right. Definitely. Yes, you can do manually. You can implement a subtractor circuit also, but two different process for addition and subtraction there. But here only one process. That is the difference. Now let me complete the advantages and disadvantages. What is the advantage of one's complement representation? Extending the range is to extend the range is easy. We need to copy MSB repeatedly. Second, if there is any carry in the addition, we need to add it back to the result. This is the disadvantage. Why? It is taking extra time. I need to take this and add it back. Why to do that? If directly get the result, it is more advantageous for us. Yes or no? So this is a little disadvantage because you need extra effort here. You don't want that extra effort. I don't want to work here again. So for that, another disadvantage is 0 is having two representations. We can overcome these two by which one? Two's complement representation. So we are going systematically one by one. Why this? Why not this? And next one. So now we are going to the next one, that is two's complement representation. This is a bad question, Manjunath. Why I said it is bad? My dear friends, I want to tell you, not only Manjunath, everybody asked the same question. Okay. Why? Because I already told the syllabus of you, okay, it is in the syllabus only. It is in the syllabus 100%, okay. It is in the syllabus of electrical, okay. CSC, everything first class, I already explained that part, okay. What I want to say is every time when you are in the class, you try to learn the new things. Your aim or your life aim is not only GATE exam, my dear friends. You should learn the subject. This is your first thing intention. Okay, that you keep it in your mind. Every day you are learning something new, something extra. That is what required. Sir, if this comes in exams or not, if this comes in the exam, can I do it in 2 minutes? Will it happen in 1 minute? How to deal this question? Every time, don't think your mind with respect to exam only. Okay, learning should be joy, not for exam, not for the result. Forget about your result. Enjoy the process. Okay, not only for microprocessor, all chapters we use ones and zeros only. These basics will help you. Okay, subject, you learn subject, you enjoy the subject. Automatically your questions and marks will come as a byproducts. Okay, so don't think whether I can do this question in exam, how this question is asked, whether I will get it for 2 marks. For that only we are practicing the questions. Okay, for that purpose only we are practicing the question. If I need only for GATE, if I want to train only for GATE, I can simply take the questions and explain you, and from the background I can explain you the theory. That is also another way. Okay, Try to involve in the class, learn the class. Okay, as he asked, I am saying for everyone because everybody asked the same question. Sir, will it come in exam? Will it come for 2 marks? Okay, all those things, forget about it. Learn the subject. Yes, very good. Okay, Behra, what you said is correct. Learn the subject, remaining things will come automatically. Okay, so let's come to the class, the next part. Signed two's complement representation. In signed two's complement representation, if number is positive, it is represented as it is. If number is negative, it is represented by its two's complement form. So here small understanding is required. Same as previous. What is the difference? इसमें difference क्या भाई? Difference. What is the difference? There one's complement. Here two's complement. That's all. Only difference is there one's complement. Here two's complements. Okay. Let me take first positive numbers to avoid confusions. 0, 1, 2, 3, and so on up to what? Yes, right, Kumari, 0 to 7. Okay, it is 0, 1, 2, 3, and this one is your 7, plus 7. Now, for negative numbers, what we do? Positive numbers, negative numbers. Okay, now what to do? Take its complement and add 1. Take its complement and add 1. Like that, what you will, let me write it first, then I will explain. Okay. This will be equal to how much? Tell me. This will be equal to how much? No. Please tell. Comment. No, minus 1. That's the difference here. Minus 2, minus 3, minus 4, minus 8. Why minus 1, sir? See here. I hope yesterday class you have attended. I told the trick, easy trick to find 2's complement. What is the easy way to find 2's complement of this? Take up to first one as it is. Remaining को complement करना, complement the remaining part. 000 will become 111. Okay. Similarly, take up to the first bit as it is. Take remaining complement, that will give you 1110, which is minus 2. Okay. Then why, sir? What happened to minus 0, sir? Where is my minus 0? Let's try. Let's try the minus 0. So 0 is having here plus 0. Plus 0 is what? All zeros. हाँ, 0 तो गया. Minus 0 is you take complement of this and add 1 because it's 2's complement now. You should take complement and 1. Then 1 plus 1 sum 0 carry 1. 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 Carry को neglect कर लीजिए. You just neglect this carry. आपका what is the answer? Same as this one. Take its 2's complement, you get back the same. That is here you don't have the disadvantage. 0 is having only one representation. Okay, so because 0 is represented only once, your range is extended previously up to minus 7 up to be minus 8. Here carry will not be added. I will prove it. Just wait for some time. Okay, it is not like previous case. Don't take this carry and add it here. Here neglect the carries. So all disadvantages are vanish here. That is the reason we use this in your computer. Okay. Aditya, what happened? Yesterday I told now what is the 2's complement, how to find 2's complement. What is the 2's complement of this number? Take 111 plus 1. You get this number. Okay. So you have any problem, Shiva? If 0 comes in the positive, computer is happy. Yes. Here 16 is having 16 different numbers. Now your range body over range increased. What is the range? Minus 2 power, so minus 8 to plus 7. That is minus 2 power n minus 1 to. This range is important. N number of times they have asked in IES exam and GATE exam. Is it okay? No problem. Khan. Yeah. Computer happy, so I'm be happy. What is so? What is this 1000? According to you, Reddy, please tell me what is this 1000? Calculate and tell me. How minus 0 comes? Khan answer is 0 ka complement. Please complement 0. All ones. Add 1 because 2's complement is 1's complement plus 1. 1's complement plus 1, right? 1's complement plus 1 is 2's complement. So apply this and add it. You get all zeros only. Khan. Now any other doubts? Range is improved. Okay, previously minus 7 to plus 7. Now it is minus 8 to plus 7. Yeah, tell me. For plus 7, you use yesterday trick, no problem. 1 and remaining 1, 0, 0. Yes, 1, 0, 0, 1 is minus 7. 1, 0, 0 is minus 8. What is the problem in this? You see the order. Decrement, 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 and next number will come. To understand this properly, take 5 bit. See here, you have 16 numbers. 1 is already gone for 0, so you definitely get 1 extra. Na? So if you want another analysis, listen please. If you take n equal to 5 bits, what is plus 8? Plus 8. What is minus 8? 1, and up to this you take as it is. Okay, I already told if you have sign extension, you write it as 1 0 0 0 1 1 0 0, all ones 0 0, all are same only. All will give you same minus 8 only. So here, can I prove that sign extension method? Suppose here n equal to 4 bits. You take the plus 7, 0 1 1 minus 7 is, what is minus 7? 1's complement plus 1. I'm directly writing by using our yesterday trick up to first bit as it is remaining complement. Very good, very good. Everybody is using, happy. So if you use n equal to 8 bits, what is plus 7? All zeros, 0 1 1. What is minus 7? Up to first bit as it is remaining complement. 1 1 1 1 1 1 0 0 1. Now you see it is nothing but sign extension only. So the previous logic is valid here also. Yes or no? So it is simply sign extension. Okay. So you don't have this disadvantage. You don't have 0 disadvantage. Next come to 2's complement arithmetic. Examiner is asking this only regularly. Okay, 2's complement arithmetic. Very simple rule. If you want to do a minus b, it is a plus 2's complement of b. Okay, if you use this method, what is the advantage? See here. If you take n equal to 4 bits, let me take, okay, 5 as the same rule, same number will take and do it. 5 is 0 1 0. What is 3? 0 0 1 1. What is minus 5? You should tell our trick. 1 0 1 1. Very good, very good. minus 3, 1, 1, 0. Very good. Now, if you want to do 5 minus 3, you know the answer is 2. So 5 is 0, 1, 0, 1. Minus 3 is double 1, 0, 1. Add both. 1 plus 1, how much? Sum 0, carry 1. 1, sum 0, 1 plus, sorry, sum 1, carry 0. 1 plus 1, sum 0, carry 1. 1 plus 1, sum 0, carry 1. Now, happily neglect this carry. Neglect the carry, you got the answer plus 2. No need to take that carry and add it back. So your computer is very happy now. That's why in your microcontrollers, microprocessors, internally they will be using 2's complement representation mostly. It helps your hardware internally, speed, everything will depend on this. Okay, everything, every minute point is important in the design. Oh, nice quotation, Asif. If you ignore everything, you will be very happy. That is true. आसिफ जी को तालियां देना चाहिए. So 3 minus 5. Minus 5 means right. You know more, you worry more. So now listen. Yes, as Behra said, don't follow in your exams. 1 plus 1. Okay, what is the answer? Sum 0, carry 1. Sum 1, carry 1. Okay, 1. Sum 0, 1. Yeah, you are no carry. Same rule. Answer negative and in 2's complement. Okay, so 1110 is how much? My dear friends, check it here. 1110 is how much? This is nothing but minus 2. Okay, so if you want for magnitude, take, this is just for understanding, it is not process of the question here. Okay, take 2's complement of 1110. That will give you 0010. That is minus 2. Okay, this is just to understand easily. Okay, take the complement, 2's complement, you get the value which will tell you what is its value. So from all these conclusions, you can say 2's complement is the best method to represent because it is not having any kind of disadvantages like 0 of 2 representation, sign extension is easy, and also no need to add the carry. You can neglect the carry. So all these, okay, everything is summarized, my dear friends, here. So everything is advantages in the 2's complement. Okay, and I also give you one small table. See this unsigned magnitude representation range. We have discussed this part, because exam it is most frequently occurring. Let me give it in the tabular form so that you will not forget. Okay, right. So this is, I am writing here also, best method.